Hello, in this tutorial we will learn how to implement a programmable discriminator using a CDK development kit and SCI-Compiler. In particular, we will learn how to implement a USB controlled register inside the firmware in order to set the threshold of the discriminator, and we will learn how to use the integrated tool Resource Explorer to access to this register via USB and set and control the threshold value. We will implement this discriminator on the following hardware. So we have a CDK development kit board connected to a digital emulator, so a pulse generator. The emulator generates an analog pulse, an exponential pulse. We can see it on the oscilloscope, and this pulse is provided to both the board and the oscilloscope. In order to implement this firmware, we need to open the SCI-Compiler software and start a new project. So we press New Project, we select the CDK board, and we set the name for the project. For this project, I will call it CAEN SK002 underscore Programmable Discriminator, and we store it in the default folder. We create the project. Okay, we want to implement an analog discriminator. That means that for sure we need to read the data from the one channel of the ADC. Then we will need a comparator and a register that will store the threshold. We will access to this register via USB, and we will set the threshold using a software. Start by placing the analog input, so toolbar, board pin, analog in, select the first one. Then we need a comparator, so toolbar, comparator, greater. We can leave it everything unchanged. Remember, this ADC is a 12 bits ADC on this board. Other board like the 5560 has a 14-bit ADC. In any case, all boards in SCI-Compiler use a standard 16-bit bus for the analog signals. So the bus will be 16-bit. Now we need to create a register that we will read inside the software, inside the firmware. So it's written by the computer, but read by the firmware. So we need a register. So we select toolbar, register read. And now the software asks us to choose which kind of register we want to create. So for us it's a bit vector, 16 bits, to be compatible with the analog signal, and we can call it as we want, for example threshold HSRD. We can press new, select the register, press OK, and now we can connect to the comparator. From the toolbar we pick the LEMO 0. By default this is an output. If we connect true to the true constant to the direction, it will become an input. And also if we want, we can add a LED. So digital output LED 0, and connect everything. Okay, that's all. Before start to compile this firmware, we need to map the register on the bus. Every element that is memory mapped inside the SCI-Compiler project require to be assigned to a register address. This memory address identify in a unique way the programmable element inside your firmware. In order to do this, we need to choose a memory mapped tab in the mapping tab in the software, and press refresh just to see that all register and peripheral are discovered by the tool, and press auto assign to assign an address to the element. We can also manually assign an address by check manual assign it and set the address. This feature is useful if we have already developed the software on the computer side and we don't want to change the addresses of the register or of other peripherals. Once we assign an address, we can press compile and generate the firmware. As soon as we start the compilation, the SCI-Compiler generate a Vivado project and then invoke Vivado to compile the bit stream. As soon as Vivado finish to generate the bitstream, a message successful compilation will appear on your screen. At this point, we can simply proceed to download the firmware on your board. In order to do this, we have to put the board in bootloader. So move the switch on the right position and power cycle the board by removing and reconnect the USB. The bootloader LED will stay fixed on. It means that the bootloader is running on your board. At this point, we need to generate the flash file and program the file on your board. So just press Flash Program Tool, select CDK, press Next, and press Start. Wait that the software download the firmware on your board. Okay, now we can press Boot Application, and we can see that the LED now is flashing blue, and it means that your firmware is running on the board. Close the programming tool, and now we are ready to set up the threshold. As you can see on the oscilloscope, the threshold by default is set to 0 because the register is initialized to 0 at the reset. So with a threshold of 0, this is well below the signal signal baseline. So the signal is the output signal, the digital discriminated signal is always high. Remember that this is a bipolar ADC, so it means that 0 it is the level 2048. Above this value we have a positive signal. Below this value we have negative signal. So how to set the threshold? There is a way that accelerate the debugging of the firmware. SCI-Compiler include a very basic tool but powerful tool that allows you to set a register and download waveform, download list, in practically control any of the memory mapped SCI-Compiler block that is available inside the SCI-Compiler without writing any line of code. Okay, this is a basic access, to a register level access. So, for example, there is no conversion between LSP and the voltage, or between nanoseconds and the samples, but you can, in a very easy way, test that your firmware is correctly working. Okay, to open this tool, we have just to click on this icon, Resource Explorer icon here. Select the model of the board, CDK. The tool will automatically identify the board, press Connect. And here we have a list of available resources. Here, this is a very simple firmware. Do you remember? We have just, if we have a look to the diagram, we have just one register. And this register is the threshold, and so it's just a numeric register. There is also a second register that we didn't add it to the design. This is the analog offset. This is a register that is automatically introduced by the board support package. So it is something that comes with the CDK board and is useful to regulate the analog offset in order to use the dynamic of the ADC. In function of the signal polarity and amplitude that you have. This is typically of this board. Other board like R5560 has different or has no this kind of register. So at this point we can proceed to set the threshold. Do you remember we have this? Our situation is that we have the input generated by the pulsar and the output is always high. What we can do now is to open the register by right click on the register name, press set and get. We can choose the format we want to write or read from the register, assigned decimal for us, and we can enter the threshold. Try with the threshold 3000, that was what we set in the example 1, that was fixed. Press set and have a look to the oscilloscope. The signal is very similar to the signal of the AEN CAEN 001. So it's we are discriminating at about the half of the amplitude of the signal. Now, if we make this, we change the threshold to 2500, for example. You can see that the signal drops. The discriminated signal become longer because we are reducing the threshold. If we reduce again 2400, longer again. If we make it higher, 3300, become shorter, 4000, shorter again. In a very simple way, we implement a discriminator using a SCI-Compiler and its programmable logic capabilities, and we can program this discriminator remotely using on this board, the USB, but on another board, for example Ethernet, and now we can develop a custom application to regulate the register or doing something more complex.